Okay, hopefully this is the last part of lesson 3.2 quadratic functions. So we'll call it part 3. We start out with example 5, asking us to find the maximum value of a quadratic function. And I need to remind you that the only way we would have a maximum value is if the parabola was upside down. So if it's upside down, we would have a maximum value at the very top. That would be the vertex. It happens at h, and the height of that is at k. That's called your vertex. And so that's what I'm expecting to find, that I have an upside down parabola once I set this up. Let's see what the problem is. We have a farmer. This is a backyard farmer, so he's planting stuff in the backyard or raising animals in the backyard. He wants to enclose a rectangular space for a new garden. There it is. He's planting some vegetables. And within her fenced backyard, okay, she has purchased 80 feet of wire fencing to enclose only 3 sides. And she will use the section of the backyard fence as the 4th side. A section of the backyard fence as the 4th side. Okay, so we're going to, I kind of have a picture in my mind. Find a formula for the area that's enclosed by the fence if the sides of fencing perpendicular to the existing fence have length L. Then B, what dimensions should she make her garden to maximize the enclosed area? So I'm picturing like there's already a fence in the back, okay? So I'm just going to draw this, and that's my existing fence. Existing. And Farmer Jane has bought 80 feet. And it says that the pieces that are perpendicular to the existing fence, so perpendicular means a right angle. So I have 2 of those. And it says here, I'll find it for you. Find a formula for the area of enclosed by the fence if the sides of the pieces, the pieces of fence that they're perpendicular, and we're going to call it L. So that's L. So if that's the case, then I have another piece. I guess I'll make that green. And I will call that, if, we're doing a rectangle, we think of rectangles with lengths and widths. So there's my length, and I'm going to call this my width. What do I know right now? I know that the perimeter of fencing that I purchased is 80 feet. So I know that my perimeter right now would be 2 L's and a W. And that has to add up to 80 feet. So I may need that as I try to put together the equations for area and try to maximize it. So I think the next slide already set the picture up. So here is the same problem with the same picture, reminding you that this was my back fence that I'm going to use. And so it really doesn't matter how long I draw that fence, because I'm only going to make a rectangle from here to here. And we'll find out that's my W here. We'll find out what that number's got to be. So I'm looking at that perimeter again. It was 80. So I'm going to write that again. I had on the other slide 80 will equal to 2 of the L's plus this W down here. I don't need this one up here because it's already fenced in. But I do have these 2 L pieces here. So why is that important? This is like 2 variables. It's linear equation. Solve it for one of them, and I'm just going to go minus 2L minus 2L to give me my equation. W will equal to 80 minus 2L. So one of the questions that we're asking in here about the maximum area, what's the maximum area inside this fence based on the amount of fence that I have? Based on making 3 pieces and 2 pieces that are parallel, that are perpendicular to the back fence, are L's. So I need to solve that. That was a minus 2L. That didn't look like an L to me. Let me rewrite that L there. So someone's going to ask me anyway. L, 2L. And recall that the maximum area would have been, if you think about it, area of this rectangle would have to be L times the W. That's the area formula. So I already know that W can be substituted for A minus 2L, and I already have 1L. So my formula for A will be the 1L times the W, which is, I've already turned it into 80 minus 2L. Distribute that L, I get my formula is 80L minus 2L squared. That's a quadratic. See, the x, that's the same thing as an x squared. Matter of fact, if I wrote it as y and x, you might see it better. My y stands for area. That's 80x's minus 2x squared. Let's put it in the general form where the x squared goes first. That gives me my y equals to a negative 2x squared plus 80x. Clearly, that is an upside down parabola. And I think I mentioned it to you that the only way I can have a maximum value would be that it's an upside down parabola, and that's my vertex. How do I find the vertex? Well, we've learned that the vertex, we start out with minus b over 2a. And then the highest value, the maximum area, maximum a, would be coming from plugging the, I'm going to call it the a of minus b over 2a. I'm going to plug that into my a equation, which is this equation here. Because this has become my hk. Remember? hk, the height is k. That's what I'm looking for, hk. H is very important because that tells me what my fencing will be for L because X is L. So let me go and think about this for a second. Let's see. Rewrite this again. I'm going to rewrite, I'm going to put it in terms of Y and X because that might not be as confusing. To me, it's either the same either way. Y is the negative 2 L squared, which I'm calling it X for you, and then it's plus 80L. I'm calling it 80X. Notice that's your parabola. And so A is the number in front of the variable being squared, so A has to be a negative 2. B is the number in front of the X term, or the L term, 80. C is the number, if that's my A, that's my B, my C is over here. Well, there is no number, so it's plus 0. So C is a 0. So using my vertex equation, I need to find the X equals that's my H, remember? That's my H, is opposite of B over 2A. Let's plug in what I have. This will tell me what my L is. My HK, that H means X, the X means L. So minus B, that's minus 80. I don't know where I wrote that. Oh, let me erase that. Wasn't even sure. Not going back any further. So I was going to minus 80 all over 2 times A, which is 2 times a negative 2. 2 times a negative 2. That turns into a minus 80 over a negative 40 is positive 20. That was feet. Remember? This is my length because that was my x. My x is the length. So I already know that this is 20. This side is 20. This side is 20. I only have 80 feet of fence, so 20 plus 20. I can figure out what my W is because I have this equation here. The W would be 80 minus the two L's. The L's 20, so W is 80 minus 40. So that gives me 40 feet. There's my dimensions. That one's 40. 20, 20, 40. And I think they still were asking us to do, I did find the formula for area. And did it ask me to find the maximum area? It didn't tell me to find what the area would be. But I don't think that'd be hard for you to find out because area is length times width. 40 times 20. So the maximum area would be 20 times 40 will equal to 800 square feet. All right, there's your maximum area. There's my L. There's my W. Here's my equation for area. Actually, it was up here, but I changed it to y is an axis. I'm done with this problem. It's a lot of thinking. It's a good basic problem. Let's check out the authors. Okay, and I used the strategy after I found my equation. I did put the picture of the parabola, and sure enough, there's my, if I graphed that equation with a calculator, I would have found my vertex by just looking for it, and I'd have that same point there. So it looks like I had the same numbers in my work, and it's all simplified, much prettier. Found out my highest is 800, yeah, and I found out my L was 20, and it's there. There's my equation that they wanted. Yeah, it looks good. This will make more sense to you if you actually did this by yourself a couple times. Okay, move on. Finding the x and y intercepts of a quadratic function. Boy, haven't we done this already? We certainly have. I'm looking at a picture of a parabola. 3 different pictures. So let's take a look at what I'm seeing. No x-intercepts. What would that mean to you if there are no x-intercepts? And why do I know there's no x-intercepts by looking at the picture? Nothing is crossing this axis. That means there are no real solutions. Does it have a y-intercept? It always has a y-intercept. It's something up here. If I trace this up here, looks to me like around here, whatever that is. So that would be the y-intercept. That's the y-intercept. which is 0, comma, just work with me. I'm going to call it a 5. It may not be. I don't have the equation to prove it right or wrong, but it looks around 5. So there's your possibility of no solutions for this quadratic function. This one, because the vertex is touching the x-axis, there's one x-intercept, one real solution. As always, there's always going to be a y-intercept. That would be my y-intercept. That looks to me like 0, 3. Just bear with me. Just pretend it's true. Here's the third possibility. If your parabola crosses the axis in 2 places, 1, 2, that would be 2 real solutions, which corresponds to 2 x-intercepts. Now, though that 0 here has an ordered pair, that to me looks like 2 comma 0. And then these looks like 1 comma 0 and then 3 comma 0. Notice there's 0 on both of those because it's crossing the line y equals to 0. What will I do with this? Let's see. Given 2 quadratic functions, giving a quadratic, find the x-y-intercepts. Well, it's the same thing when you're looking at it. If you're finding the x and y intercepts, find out what f of 0 is. Find out what happens when the function's crossing the x equals to 0. That's what this is. X is 0. That'll give you your x-intercepts. And, I'm sorry, your y-intercept. One y-intercept. The x-intercepts, that even says that right here, y-intercept. The x-intercepts would be if you take your parabola equation, your quadratic function, set it equal to 0, and then solve it. This requires solving. What have we done in part 1? We use the quadratic formula, remember? That's one way. That is one way. Okay. That whole page was just to talk about that picture. Example, how to graph. No, it doesn't say that either. It says given a quadratic equations. Oh, that's the same thing. I don't know why I repeated it. Oh, I put it there so you could have it here when you did this example 7. I forgot. Find the y-intercepts of a parabola. So here's your equation. Find the x-y-intercepts. So this function, f of x is 3x squared plus 5x minus 2. Let's find the y-intercept first. That's the easiest. Remember what I said before. X has to be 0 because that occurs right here, somewhere on this line, somewhere there. Let's try to find it. So f of 0 means this gets a 0 and this gets a 0. That's 3 times 0 squared plus 5 times a 0 minus 2. 0 squared is 0. 0 times 3 is 0. 5 times 0 is 0 minus 2. FYI, if you have your equation in general form, this answer will always be your y-intercept. 0, negative 2. 0, negative 2. Boom, boom, there it is. Now we're going to find the x-intercepts. I take my f of x for my x-intercept. I say let f of x equal to 0. So I'm going to write it out. 3x squared plus 5x minus 2 is 0. Now, we could factor this maybe, but we didn't do factoring on part 1. So I'm just going to do quadratic formula real quick. And I say real quick knowing I can make a mistake. my x's will be opposite of b plus or minus square root b squared minus 4ac all divided by 2a. Memorize it. In this problem, a is a 3. B is a positive 5. C is a negative 2. And if you plug everything in carefully, you'll have the answer. And I don't know if there's 1, 2, or none. I don't know. X is opposite of 5, negative 5, plus or minus square root of 5 squared, 5 squared. I always write minus 4, then I put a parenthesis to do my a times c. What's my a? A is a 3. What's my c? Negative 2. You have my permission to say, what's 3 times negative 2? Negative 6. All of this divided by 2 times a, is 2 times 3, which is 6. Now let's clean that up. Equals 2. I don't know why I don't take it off. Negative 5 plus or minus square root. 5 squared is 25. And I want you to be careful. There's a minus here. There's a minus here. That becomes a 25 plus a 4 times 6. 24. 4 plus 24. All over 6. Negative 5 plus or minus square root of, what's 25 plus 24? Did you say 49? You're right. All over 6. Since that's a very perfect square, I know I could have factored this. If maybe in class I'll do this problem again, and just to show everybody that after you go through it, I'll want to take a break, show you. Negative 5 plus or minus the square root of 49 is a 7. All divided by 6. Almost done. So x will be a negative 5 plus 7, negative 5 plus 7 divided by 6. And another x will be negative 5 minus 7, all divided by 6. So remember, it's all you got to take it all divided by negative 5 plus 7 is a 2. 2 over 6 becomes a 1/3. There's one of your zeros. 1/3, comma 0. There's 1. Let's do the other one. Negative 5 minus 7 now is a negative 12. 7 plus 5 is 12. Keep the negative divided by 6. That's a negative 2. So the other answer is negative 2, comma 0. Those are my x-intercepts. And my y-intercept was, did I find it? I thought I did. It was a negative 2. Did I write it out? Y-intercept happens at a 0, negative 2. Okay, let's see if we're right. Same page, let's see. Let's look at the picture. Picture should have everything. 0, negative 2, score. 1/3, comma 0, score. Negative 2, yes, I love it when a plan comes together. I love it. That's exciting. Having to redo that problem again would not be exciting. Okay, we're on another example, this example 8. Just find the x-intercepts. Yeah, that's all. Not hard at all, right? It's a lot of work. Yeah. So, I don't want to do that. F of x is 2x squared plus 4x minus 4. So in order to find x-intercepts, I need the a, the b, and the c. So it wouldn't hurt to make this a little bigger here. A would be a 2. B is a 4. C is a negative 4. Don't forget the equation. To find the x-intercepts, those are my solutions. I'm solving this quadratic. X equals the opposite of b plus or minus square root of whatever b is, square it, minus a 4. And don't remember, I always say a times c, which in this case, I'm just going to put it first. This whole thing divided by 2 times a. Let's plug in what I have. X is opposite of b, opposite of 4. Plus or minus square root of 4 squared minus what? Minus a 4. Always minus a 4. Times what? AC. So my A is a 2 and my C is a negative 4. That's a negative 8. All divided by 2 times a 2, which is a 4. Let's see if we do the math correct. Equals to negative 4 plus or minus the square root. 4 squared, 16. Minus minus becomes a plus. 4 times 8 is 32. All divided by 4. So I'll simplify it one more time in the same row here. Negative 4 plus or minus, because there's 2 answers. Let's do the math right. 16 plus 32. I think it's 48. 48. All divided by 4. What do I do with that square root of 48? It's not perfect. So equals to a negative 4. I break that 48 into 2 numbers. One has to be a perfect square. Start with the 4, then check the 9, then check the 16, then check the 25. Well, I'm going to stop at 4 because I know 4 goes into 4 and 4 goes into 8, so a 4 must go into 48. So I'm going to make that a plus or minus a square root of a 4 times 4 goes into 48. 4 times 12 is 48. You can use your calculator and take 48 divided by 4 and see what you get. Beautiful. All divided by that 4 again, and keep going here. And what I do here, I break it apart. I take both of these pieces and break them into their own square roots. So that gives me a negative 4 plus or minus the square root of 4 times the square root of 12. And I realized something. I could have done a better job, but I didn't see it before. So you're going to see it now. Still divided by 4. I could have shortened it up. Equals 2, but I didn't. Negative 4. That square root of 4 here becomes a 2, plus or minus a 2. And then I have a square root of 12 divided by 4. Now, what do I mean I could have done it better? The 12 can be broken down into 2 numbers, 4 times 3. So I'm going to continue this and do the same thing. Negative 4 plus or minus a 2 times the square root of 4 times the square root of 3. Still divided by 4. The fun just never ends. Okay. That turns into equals to still the negative 4 plus or minus 2 times what? What's the square root of 4? 2. 2 times 2 comes out. I'm still stuck with that square root of 3 divided by 4. All divided by 4. Don't give up, guys. Don't give up. Equals to a negative 4 plus or minus 2 times 2 is a 4. Square root of 3. All divided by 4. Well, that's good news because if I have a 4 here and a 4 here and a 4 here, they all cancel. So what's a negative 4 divided by 4? A negative 1. Plus or minus. I'm left with the square root of 3. And then 4 divided by 4 is a 1, so that's my answer. Those are my two answers. How does it really look? -1 plus square root of 3, comma 0. Let me make that stand out a little better. Or just erase the whole thing and do it again. Plus the square root of 3, comma 0. And -1 minus the square root of 3, comma 0. Those are your actual real answers for the x-intercepts. If you used a calculator on this piece here, you're going to get decimal numbers. That's fine. You can do that. I wouldn't be against it. Matter of fact, probably the author did that. Let's see. Same problem. That's all the work that was done. Oh, they did it a different way. It's okay. I did quadratic formula. They converted it into standard form, created a standard form equation, set equal to 0, same kind of thing, and then solved it. Look at, I see the same answers. I think I had a -1 front. I hope so. Nonetheless, they look very familiar. See, there's more than one way to do it. You do it either way. Do it both. That's good practice. Try this. This one's on your own, and I'm going to resist the temptation. I will probably put this problem on a quiz. So figure it out. I'll give you one hint. Only because, that's the way I roll. G of x, I'm going to move these things around. This should be first. 1x squared. I'll just write x squared. Then this has to be second because it has an x minus 6x. Then your 13 is the out here. Okay, I'm going to let it ride with you. And solving a quadratic equation with a quadratic. I just got done doing 2 of those in a row. Okay? So I'm not going to do it. You can do it. I think I may have put the answer here. Let's see. This was x squared plus x minus 2. Oh, it was plus 2. Yeah. Yeah, did I? X squared plus x plus 2? Going back again. All I did is put the quadratic formula. Go ahead and knock yourself out. Maybe I didn't follow the directions on the other 2. Maybe I was supposed to use standard form. I don't know. It doesn't matter. I'll go back and look at it another day. There it all is. So you have it solved. So you don't need me, but you should do it on your own. Example number 10. Applying the vertex and x-intercepts of a parabola. So they're talking, when they say apply, it probably means a real world scenario. Yay. A ball is thrown upward from the top of a 40-foot building at a speed of 80 feet per second. The ball's height above ground can be modeled by the equation. The height, h of t, equals a -16 squared plus the 80t plus the 40. We've talked about this before, and so there's always going to be a -16 in front of a parabola when we talk about an object that goes up and comes down, always, because the acceleration due to gravity is a -32 feet per second squared. And that's with the acceleration. And we take half of that. So we get the -16 in front. And then the speed, the initial speed will always be the b. It's what's here. So and this is my initial height. Why? Because there was a building of 40 feet where the ball was thrown. So you notice you have a parabola, but on the left side of the vertex, it didn't really start at the bottom. In theory, it did. But if you're standing on this building, you weren't at the bottom. But the pathway still goes to the ground, just like it did on this side. And so I'm going to still say to you, A is going to be a negative 16. Actually, the acceleration due to gravity is 1/2 a, negative 1/2 a. Why is it negative? Because gravity pulls the ball down, and so that's why you get an upside down parabola. B is 80 feet high. That was where I was at on this building. And C, oh, I messed up anyway. Let me erase it. Yay. B is 80, but it's not the height of the building. The height of the building was the 40 that I wrote down to begin with. C is 40 feet high from the building. And I've already labeled it here once before. Anyway, A, B, and C. So what do they ask us to do? When, not what is, when is the maximum height reached? B says, what is the maximum height? Well, guys, this is my H, and this is my K, HK, if I was doing standard. And you could easily do the vertex. C says, when does the ball hit the ground? So that's a good question. When does that ball hit the ground? How long will it take? So in reality, time is this axis here. And then you have this y-axis here. So that would be my time, that's my x. And this is my height, that's my y. So if I just write y equals to negative 16 x squared plus 80 x. You see how there's a t here and there's a t here squared? It's the same thing. So it's not anything different. It's just the variable that you use. So you can keep it with x's or you can put the y's, okay? And since I'm going to stick with the problem, I will change my y to be the height. And I'll change my x's to be, whoop, I did not want to do that. Kind of looks pretty, I guess, for Christmas. Change my x to be t, just because. And in reality, that also makes my h to be h of t. So h of t, because I'm plugging in t, is that t squared t. So I went back to it just because, keep with the original equation. So what's my vertex? Remember again, vertex is found at minus b over 2a, comma, in this case, h of minus b over 2a. So let's find that first. Let's find the letters that I used was h and k. So let me just not call it, let me just do minus b over 2a is minus 80 over 2 times a negative 16 minus 80 over a negative 32. The good news, that the two negatives cancel. And I'm left with 80 over 32. I can reduce that to 40 over 16 because I don't want to do the pick up a calculator. I can reduce that to 20. I like to do this a lot where I just cut in half. 20 over 8. I can do it again. 10 over 4. I can do it again. 5 over 2. I'm done. That's 2.5 equals 2.5, whichever way you want to use it. So then I got to plug it into this h. So h of 2.5 will be negative 16 times 2.5 squared minus 80 times 2.5 plus 40. And then I've met my match. I'm going to have to plug it into a calculator. So feel free, pick up your calculator. I'll wait for you. Did you get it? Equals 140 feet. That's that's the height of the ball. That's up there. So no, actually, that's my x was 2.5. That's down here. That means 2.5 seconds is how long it took to go halfway up from here. And then the height was 140 feet. So I have 2.5 seconds was here, and 140 feet is the height. So I answered the question, but I didn't really answer it. What does A said? What time does the ball take to reach the maximum height? That was 2.5 seconds. And B says, what is the maximum height? I think that's 140 feet. Now, I have not answered the C. That I don't know yet. When does the ball hit the ground? Now, there's a couple ways of asking you to do this problem. You know it's more than 2.5 seconds because it took 2.5 to go from the edge of that building. Technically, the other side of the parabola is over here. It's past the line here. So what we're looking for is an x-intercept, the positive value x-intercept. I don't need this x-intercept. So here we go. X-intercepts are equal to the opposite of b plus or minus square root of b squared minus 4 times a times c all over 2a. And so I'm going to need those a's and b's and c's again. Let me write it out again. A was a negative 16, B was an 80, and C was a 40. Negative 16, 80, was it a positive 40? Yes, it was positive 40. The only thing that was negative was A. So there's my A, there's my B, there's my C. So let's plug everything in. Fun. I'll probably set it up and I'll probably use a calculator. And I don't really need the negative one here. I could just deal with the positive because this negative plus all of this will be a positive number. If I kept it a negative one, it'd be a negative plus a negative would be a negative answer. I don't want the negative answer. So my x value is going to be a minus b, which is a minus 80, plus, I'm just doing the plus this time, plus the square root of b, which is 80 squared, minus 4 times AC. That's a negative 16 and a positive 40. So be careful. Negative 16 times 40. It's going to be a plus again, all over 2 times A, all over a negative 32. So I'm going to let you use your calculator. You know what, I might even clean that writing up there just because somebody, the only question they'll ask me the whole day is, what is that number? Means they weren't reading it. Negative 4 times a negative 16 times 40. There. Still divided by 2a, which was 2 times the negative 16, so it's a negative 32. With that, I'm going to just keep it negative 80 plus the square root of 8 times 8 is 64 with 2 zeros. Minus and a minus becomes a plus. 4 times 16 times 80. That's probably where I'll pick up a calculator. And I'm going to go right to the final answer over negative 32. So you can fill it in. I'll give you a few seconds to try it with a calculator. Let's see how many of you actually pick up a calculator when you're doing this in class. Okay, give it time is approximately 5.458 seconds. I did tell you it has to be more than 2.5 to get to the other side, so, or yeah, it was 2.5 to get to where it was, so, interesting. I think that's what I saw. Let's take a look at the solution. It looks like they found the same height at 2.5 seconds. It looks like they plugged in at 140, so that one's good. Then they did the quadratic formula. Look at that mess. And then I don't see them with an answer until they said, because his square root does not simplify nicely, we'll use a calculator. So did I. And, my decimal's in the wrong place. 0.458. Oh, no. 5.458. 5.458. What's this other one? Oh, that's the negative one that I told you we don't need to do. We didn't need that one. We just needed how long it took to hit the ground, and it was going to be 5.458 seconds. That was fun. This is a try it number 5, and it's the same as the last problem. So that's yours. I may use that equation for a quiz question or test question. FYI. Anybody wants to come in and work with me on it, I'll be happy. Or if you're doing it in the class, happy to help you out. And it looks like that's the end of the lesson. I will provide you with the problem sets for the paper pencil homework. Have a good one, guys.